Hello Year 11 and welcome to your next geography lesson. We're going to continue looking at coastal processes and landforms in these lessons, and I'd like to start by having a look at this photograph. A beach, hopefully fairly clearly. I'd like you to, very simple task really, write what's going on here. Consider 3 facts and consider everything you can see. 3 minutes to do that. Pause the video now. Okay, so you've been looking at a beach. Hopefully you can tell some simple things like it's a tourist beach. There's a lot of people walking and sitting and lying on this beach. Why? Well, because it's a particularly large beach, isn't it? Very wide, as you would call it, from front to back of the beach is referred to as the width. This is a very, very wide beach, so clearly very attractive to tourists. Why is it wide? Well, think back to your fieldwork. There are groins there, so hopefully you may have identified those groins. They are wooden in this case, although it's very hard to tell that really. And that may have prompted you then to think about the process of longshore drift. How can we tell it's going on here? Well, if we look carefully, I'm going to use my laser pointer here at this groin particularly, you can clearly see that the beach here is significantly wider than the beach here. What does this tell us? Well, it tells us that in this area, sediment is being deposited, and this groin is doing its job, exactly like we checked on your fieldwork investigation. So with that in mind, let's get to it. Your title is Longshore Drift. Don't forget to put the date, get your equipment ready, have a quick look at the objectives. Pause the video now. Okay, so a simple definition. Longshore drift is the movement of sediment along a coast. Sediment being the pebbles, sand, gravel, whatever it is that beaches are made of and the land is made of. Broken up natural rock is called sediment, and it's the movement of that along a coast. And look at that, there we go, fancy graphics. That's moving sediment. Write it down. Pause the video now. Okay, so how does longshore drift work? Well, there is a sequence. We begin with the start of this full sequence is the wind, and it is what's known as the prevailing wind. Now that comes in at an angle, and as such the waves also therefore come in at an angle. There's my first wave coming in. Now, as a result of this, the prevailing wind blowing at an angle, the waves swash, moving up the beach at an angle. Sediment is carried along with this. So I'm just going to use a little black dot here to show my sediment. There's my pebble or rock. My pebble or rock has now moved up the beach at an angle. Gravity then takes over, and the backwash of the wave moves straight out to sea. So there's my pebble now. Think back to your orange test and what you were looking at there at Barton, and it's the same here. Next wave comes in at an angle. Sediment is now here. I'll just do 1 or 2 more. Backwash, back out to sea. Sediment is now here. And obviously what you'll have noticed is this sediment is moving along the beach. And I'll do this as my last one. I could keep going, but that'll do. So my piece of sediment has moved from here to here. And this is what we call longshore drift, or we abbreviate to, excuse the handwriting here, I'm writing this out like that, longshore drift. So we start here at point number 1 with the prevailing wind. We then have the swash coming in at an angle. The backwash going out due to gravity straight down the beach. Notice this is not a zigzag. I'm going to use red here. This is not this movement. This part here is wrong. This part here is wrong. That is not correct. Ignore that. That's longshore drift. It is as simple as that. So I'm going to leave this slide as it is. You can come back to this and pause it should you wish. Hopefully with the abbreviations there you can remember the words. I'll go through them one more time right at the end, because on the next slide I'm going to be asking you to copy this diagram, probably a little bit neater than I have. Use rulers, use all your skills to make it a little bit neater than I can do on a mouse, on a keyboard. And then you're going to be writing what happens as a flowchart. So to go back it one more time, we start with the prevailing wind, the most common wind direction, coming in at an angle. That causes the swash of the wave to move up the beach at the same angle, and sediment is transported, is carried along with it. The backwash then travels down the beach in a straight line due to gravity at 90 degrees to the coast. The sediment moves with it. The next swash comes in at an angle, the next backwash goes straight down, and so on and so on. And this movement of sediment along a beach is what we call longshore drift. Think about it. It is drifting, moving along the shore. That's where that term comes from. Right, I'm going to move to the next slide now. Just to clarify as well, there's a link at the bottom there for YouTube. If you want to hear someone else talking about this and see a different version of this explanation, if there's anything about this that doesn't make sense, you can watch that. If this makes perfect sense, then I'll leave it up to you. You don't have to. But let's move on to the next slide. Okay, so first thing to do, as I said, was to copy the diagram on the previous slide. You can just rewind the video to do that. Do it nice and neatly. Make sure that those labels are full. Write prevailing wind. Don't just write PW like I did. Next, you're going to create a flow diagram. Flow diagram being you have a box, you have an arrow moving to the next one, to the next one, and next one. You're showing a sequence of information, and it has to be in the right order. So I've done the first one for you. Due to the what? Waves approach the beach at an what? That's the first part of the sequence, the first part of the diagram I drew. The words to use are at the bottom there. You'll have ticked off 2 words, then you move on to the next box and the next. Break this down into smaller parts. Don't just do 2 boxes where the second box is the rest of the entire sequence. Try to do 4 boxes. There's a challenge at the bottom there. It goes back to that do now as well, and something I mentioned there, so that should be quite simple now. Pause this video here now. You can rewind if you need the diagram and complete the tasks. Okay, so that's longshore drift complete. You should have a nice neat diagram labeled with all those key terms: prevailing wind, swash, backwash, longshore drift. You should have shown the sediment. You should have then written a flowchart explaining the full sequence. And now we're going to move on to what is essentially a bit of revision. The 4 types of transportation of sediment in water are exactly the same as in rivers. So copy that title down and let's go back over it now. Pause the video. Okay, here we go. You should be seeing an animated diagram now. To remind you, traction, I like to refer to it and think of tractor wheels. They're large, they roll slowly along the road. Same here with traction. This is the movement of the boulders, the largest sediment, and it is rolled along the seabed. It cannot be picked up because it's just too heavy. Next, we get slightly smaller, saltation, pebbles. These are small enough that the water can pick them up, but still large enough that it can't hold them in suspension. These bounce along the bottom. Think of grains of salt being dropped onto a table. They would bounce around before they went still. Next, the smaller sediment. This is now your sands and gravels, your smallest sediment. Suspension. Hopefully the word suspended or suspend, you should know what that means. It means to, in the air, would be to float, to hang, to not touch the bottom. So suspended sediment is exactly the same. This is small enough that the water can carry it. And finally, the invisible solution, the dissolved particles, often of things like limestone, which are dissolved into the water. These cannot be seen, but they're still there. These are the 4 types of transportation. Again, you can come back to this and have a look at this again if you need to for the next task. So here's how you're going to record this in your book. Copy and complete this. You've got 4 bits of writing with some missing words at the bottom there, and then you need to draw 4 diagrams to show these processes happening. Nice and simple. Draw sediment, draw arrows, draw the water, draw the seabed, make it nice and simple, nice and clear which is which. If you don't want to draw it out exactly as it is on the board there, that's fine. You could put traction as a subtitle, do the writing and the drawing underneath it, and then move on. As long as it's clear what goes with what, that is fine by me. So pause the video here and complete that task for me. Okay, to finish the lesson, that's it. Longshore drift and the transportation of sediment go hand in hand. They're all methods of transportation. This is how sediment that is eroded in one part of the beach gets moved somewhere else. We'll move on to deposition next. Quick little test then. Let's go back and do a little bit of a check. You've got 10 definitions. What are the key terms? So write the number 1 in your margin and write the key term, number 2, and so on and so on. It should take about 10 minutes. Pause the video now. Excellent. Here we go. Here are some answers. The last two, limestone I did actually mention today. Number 9, wave refraction. You probably actually may have missed out. This is something that a teacher may have chosen to do with you, but it might not be. If you're not familiar with that, don't worry too much. 1 to 8, however, we should be familiar with. So check your answers, make any corrections you needed to, and that is the end of this lesson. So thank you for your time. Hopefully see you and speak to you soon. Take care.